Yep. Okay. So let's look at these ones. We're going to simplify a bit. We're going to use some of our properties. We're going to use some of the things from last section. These combine a few pieces together just in little bitty bits. So log base 5 of the 4th root of 25. What do we notice about this? Yeah, so we know the square root of 25. This is unfortunately asking us for the 4th root of 25, so it's not quite the same. How could I write the 4th root of 25 in an exponential form? Like 25 to the what? 1/4. So this is the same thing as log base 5 of 25 to the 1/4. And from here, I see a couple of different pathways through simplifying. We could either use our power property to pull the 1/4 down in front, or we could rewrite our argument so that it's got the same base to cancel out there. There's a few different pathways through. I think the easiest option that I see would be to rewrite this with the same base, my 25. Because how would I write 25 with a base of 5? Yeah, log base 5 of 5 squared to the power of 1/4. Which means, what do I do with those two exponents, my square and my 1/4? Multiply them. So this becomes log base 5 of 5 to the 2/4, which is the same thing as 1/2. So log base 5 of 5 to the 1/2 is what? 1/2. They're the same base, so they cancel each other out. Log base 5 of 5 cancels out. So our final answer here is 1/2. Kind of a similar vibe on the next one. So, questions on this first one? Okay. So what could we do on this second one? Yeah. So we're going to have our 3 log base 7 of 49 to the power of 1/6. I want to use one of the power properties here, or the power property, and you could use it in either direction. I could either take my exponent, let me get a brighter color. I could either take my exponent down to bring it and be a multiplier, or I could take this multiplier up and put it in the exponent. Either way is fine. I have a tendency to bring things in to condense it more. So I'm going to go this way. The number out in front is a power, so it multiplies against our power. So this is the same thing as having log base 7 of 49 to the 3/6. 1/6 times 3 gives me 3/6. What does that simplify down to be? 1/2. So we have log base 7 of 49 to the 1/2. What is 49 to the 1/2? 7, because that's just the square root of 49. So this becomes log base 7 of 7. What's that equal? 1. So we can use those properties to try and not have to figure out each of these individually. We can kind of mush things around to make them into the Play-Dohs that we want them to be. Questions on these two? All right. One more evaluate, kind of like this, because I wanted to work our e's in. And on this one, we could use any number of properties. I could use my power properties to bring exponents down. I could use the power property to put the coefficients up. I could use the natural log of E being inverses of itself. I could use all kinds of pieces here to simplify this. There are many pathways through. So looking at this one, what do you guys notice? Which path do you want to take? Yeah. These two, ln and e to the, are inverse operations. So we're going to be just left with this power. So we're going to be left here with 36 times 0.5. And the same thing happens on the next one. I have e to the and ln. So my natural log and my e cancel out, and we're going to be left on the right-hand piece with our 4 times our exponent, which was 5. So we have 36 times 0.5 minus 4 times 5. 36 times 0.5 gives us what? 18. 4 times 5 gives us 20. 18 minus 20. I ask such hard questions sometimes. Oh my gosh. 18 minus 20, the hardest question. Okay, so the evaluating statements sometimes use properties, sometimes they don't. Just be careful with which pieces you look at, okay? What we're going to focus on mostly today is using those log properties we had on that first page to do some expanding and condensing. So expanding means I'm going to give you a log statement, and we are going to make it as big as physically possible. We want only one piece after a log of each term. So I give you log base 6 of this statement. And we want to expand as much as possible, which means every log, every time we write a log, when we're done and we get all the way to the end, it should just have our log base B, whatever our base is, of one single thing here. There should not be any multiplication, addition, well, it could have addition, no multiplication, no division, no powers inside our argument. So this needs to just be one letter, one number, one term. That's when we are done expanding. If you have log base whatever of x, log base whatever of w, log base whatever of 2. Not x to the 7th, not xy, not 2 to the 4th. Individual pieces. So when we're working with these properties, I gave you kind of an order at the beginning on that first page where when we're expanding, we're going to kind of go from top to bottom, starting with the quotient property, then do our product property, then do our power property. It's not law, it just gives you a really good order of operations to use. So the first thing we're going to use when we expand this one is our quotient property. First thing I need to do is I need to split this division into subtraction. So we do our log of the numerator minus the log of the denominator. So our first thing we're going to have is we're going to have our log base 6 of our numerator, so our x to the 7th. And then we're going to subtract log base 6 of y to the 4th. That's using our quotient property. I don't have any products in these, so we're not actually going to need to use our product property on this one. And then our next piece is to use our power property, where I take my exponents and they're going to come down and be coefficients out in front, like this. So we're going to have 7 log base 6 of x minus 4 log base 6 of y. Each of my logs only have a single term in them. I have just an x, I have just a y. So this is my final answer. This is my fully expanded logarithmic statement. What's up? We cannot. If I had log base 6, like 7 log base 6 of x and 4 log base 6 of x, then I could combine like terms together. But that means that this piece would not have been fully simplified. So we shouldn't really be able to combine like terms once we get it fully expanded. The next one is very, very similar. But questions on the first one? Okay, so we're going to do our quotient rule first. So this is going to become log base 5 of our numerator. So my xy squared minus our log with our same base of our denominator, w. So now I don't have any more division in any of my logarithms, but I do have a product here. So I need to use my product property on this piece. So this guy's going to expand outwards further, because I have in here x times y squared. So this is going to become, make sure I face, log base 5 of x plus our log base 5 of our y squared minus our log base 5 of w. What's up? We'll tell you in the instructions. If it's evaluate, you should have a lot more numbers in it. If it's a lot of letters, it's just going to be expanding. Because we have one more thing we can do here to expand this even further. I need to have just one thing after my logs. This piece has 2 things after the log. So we need to take this power down and have it be a coefficient. So my powers come down and become multipliers. So our final expanded, fully expanded logarithm is our log base 5 of x plus 2 log base 5 of y minus log base 5 of w. And every single one of my logarithms just has one single piece in the argument. Just one x, just one y, just one w. So this is my fully expanded form. And I know it's awkward and kind of weird and it feels very strange. The reason we have this is because in equations, if I was trying to substitute in variables to get an actual numerical answer, these calculations are easier than trying to do the logarithm of something like this over and over and over and over again. So that's why we have the expansion, is it makes it easier to actually calculate values when dealing with formulas that have logarithms in them. We're going to practice a couple more. So, questions on these two? Boop. So we've got ln, our natural log of 3wx squared over y to the fourth. So what are we going to do first on this one? Yep, our division becomes subtraction. So it's going to become natural log ln, we're just going to keep using that one, of our numerator, so our 3wx squared, and division becomes subtraction, natural log of y to the fourth. Then what are we going to do? Yeah, our multiplication in here becomes addition. I have two multiplications in there. So this is going to become kind of long. We're going to have our natural log of 3 plus the natural log of w plus the natural log of our x squared, and also then minus our natural log of y to the fourth. So fully separating each piece. We are not keeping coefficients in there. We're not keeping anything together. I need all of my logs to just have one thing after. So just be careful with that. And then our last piece that we need to do on this expansion is to bring down our powers. Our powers need to come down and be our coefficients. So our fully expanded out version, the first two don't change at all, our natural log of 3 and our natural log of w plus 2 natural log of x minus 4 natural log of y. When our logs have just one thing after them, that's when we're done expanding. The argument should have one single solitary term. That's where we stop expanding. Okay, questions on that one? Very similar vibe on the next one. Same kind of process, it just has more pieces. There's one piece we have to watch out and be careful for. Our first is exactly the same. We're going to take our numerator and our denominator and split them. This is the common log, so it has a base of 10. We don't have to write that in there. So we're just going to use our common log of our numerator, 9v to the 5th x, subtracting our common log of y squared w to the 4th. when I come through now and I take my multiplication and make it addition, we need to be super careful that we subtract this whole piece. So when I'm switching this multiplication to be addition, I need to make sure we have that pair of logs in parentheses so we wind up with correct signs. So this one's going to get really long. I'm going to skip a couple of lines just so I wind up with plenty of space. So this is going to come down here. Because we have a lot of pieces here. So we're going to have our common log of 9 plus our common log of v to the 5th plus our common log of x minus the common log of y squared plus the common log of w to the 4th. Ooh, guess I kind of overcompensated on that size. I can't make it bigger. It's really important to notice that these two pieces were added together after they were subtracted. So they both going to wind up being negative signs. We do want to get rid of these parentheses as we're expanding. So when we're coming through to do our power property, I'm also going to distribute this minus sign through so that we can write it without parentheses. So as we're doing our power property, I'm also going to deal with this minus sign over here. Because our fully simplified answer, there we go, this. We're going to have our log of 9, that one's not changing at all, plus 5 log of v plus log of x minus 2 log y minus 4 log w. We want only one term after the log, and we want no parentheses anywhere. So each of these logs have only one term in the argument. So it's fully simplified. That's how we know we're fully simplified. Just because that's honestly the biggest sticking point is usually when to stop. So this is our fully expanded outwards logarithm. Okay. 2 more expandings I want us to do, and then we'll look at condensing. So you've got log base 6 of 2x quantity squared, y to the 5th. You have a couple of ways you can approach this one. You can either come through here and simplify this, meaning take our powers and do our powers and get rid of the parentheses. So to make this 2 squared and x squared. That's option number one. Option number 2 is to just take it and do it as order of operations. So we would then deal with our exponents first and then our property, our product property in the set. You can go either direction. Honestly, I think it's going to be easier to simplify it when it's in its exponential form. I feel like we're more comfortable with our exponential rules than we are with the logarithmic properties. But whichever works better for your brain. I genuinely do not care if you simplify this statement or if you do your power property first. I think it's easier to simplify this expression so that it doesn't have parentheses over here. Because we could rewrite this as log base 6 of, It's 4x squared, or is 2 squared x squared, y to the 5th. And we'll get to the same answer either way. It might look slightly different, but you can do that. So what is this going to be fully expanded out? Let's hop the whole thing. Log base 6 of 4 plus 2 log base 6 of x plus 5 log base 6 of y. And as we get more and more practice with this, we'll start to see that, and we'll be able to do, especially when we have all products here, fairly quickly. Like, we don't have to take a ton of time to do these. You don't necessarily have to write every single step out. If you do product property and power property at the same time, I can tell what you're doing. If you need to write every step out, absolutely fine, totally fine. When it's a series of products like this, I also get that we don't necessarily need to write out every single step, most likely. On something like the next one, we probably do need to write things out because there's weird stuff that happens. Because we have sums and differences, do any of our products have sums or differences in the arguments? Do we have, in any of these, pluses or minuses over here? Do we have any addition property or subtraction property? No. Inside the argument, if there is addition or subtraction, it changes nothing. So when we have things that have addition and subtraction in the arguments, put parentheses around them because this is one unit. This is one unit. Treat them as a chunk unless they are something that we have other issues to deal with, how to work with. So the first thing I'm going to do is I'm going to switch it out of this radical property, or out of this radical form, and into our fractional index. So where we put it as an exponent. So the first thing I'm going to do is I'm going to write this as our log base 5 of the fraction with my x squared minus 1 and my x squared plus 1 to the power of 1/3. I'm putting parentheses around them. Then I'm going to do my division property so that we can expand this out here. So we're going to have our log base 5 of our x squared plus 1 to the 1/3 minus our log base 5 of x squared minus 1 . I'm going to use my power property to bring this down in front as our multiplier. And then I want us to look at our arguments and see if either one of those is factorable in the real numbers so that it could be written as a product. Is there any way to write x squared plus 1 or x squared minus 1 as a product that uses real numbers? Yeah, so my x squared plus 1, I could write that as a factored form, but it would have i's in it. And we're going to live in the world of real numbers with logs because ew. But x squared minus 1, that's a difference of squares. So this is the same thing as log base 5 of x plus 1, x minus 1. When we have a difference of squares, we can factor it, which means this is actually a product. So in order to fully expand it, I do have to use my product property over here. So if we have something that can factor, it does become a product. So our fully expanded form over here, remember to be careful because this is a product that's after subtraction. We're going to have our 1/3 log base 5 of the x squared plus 1. That one we cannot simplify. We're not putting it into imaginaries. We're going to have our log base 5 of x plus 1. We're having our product after our subtraction, so it's also going to be minus our log base 5 of x minus 1. So it's a little weird because now my arguments do not look like they have just one term in here, but there's nothing else we could simplify. So these ones are kind of gross. There's not tons like this in what we're doing, but I wanted to show one to you like this so that we could see it. But there's not tons that are like this in the homework. Okay, in fact, I believe there's one that has multiple steps like this. So that is the grossest of the expanding ones. Now what we're going to do is I'm going to give you a long one and we're going to condense it back in down to a single logarithm. So expanding means we're taking it outwards as big as we can. Condensing is we're going to get it down to one single logarithm. So they're going to be longest to write down at the beginning. So condensing is working the other direction. We're trying to get it as small as physically possible. So we've got 2 log of x plus 7 log of y. That's our first expression. So the first thing I'm going to do is I'm going to use my power property. We're going the other direction through our list. If we're not sure what to do, start at the bottom, go up. So we're going to start with our power property, then we'll do our product property, then we'll do the quotient property. So my first thing is we're going to take these powers up and make them be powers again. Our coefficients become multipliers. So this is going to become our log of x squared plus log of y to the 7th. Our coefficients go up to become powers. When we have addition between our logarithms, that's when we multiply our 2 arguments. So I'm going to bring this down to be just a common log of the product of those 2 arguments. So we're going to have my x squared times my y to the 7th. When we are done condensing, we have one single log. So not plus another log, one single log. So that is our fully condensed expression. Questions on this one? Very similar vibe on the right one. And this is where you can see why it's really important that we pay attention to our order, because we've got a product here that is being subtracted. So these 2 pieces are going to be together, but in a denominator. So just be careful with signs. So I'm still going to start with my power property, where I take my multipliers up and they're going to become powers. So we're going to have our log base 5 of z to the 6th minus our log base 5 of x to the 7th plus our log base 5 of y to the 8th. And these guys are still in parentheses. So you can choose to deal with this in order of operations, or you can choose to do this in the order that I gave you when we were looking at our properties. So you can either come in here and do our product property next, or you can set it up as a fraction. I do recommend kind of going order of operations. It'll wind up less gross looking. So I'm going to do these parentheses first and deal with my product property, even though we usually like to do quotient property. Actually, no, we like to do product property next anyway, so for sure. So I'm going to do my product property here. So this is going to be our log base 5 of z to the 6th minus our log base 5. And we're doing the product of these two pieces. X to the 7th times y to the 8th. Then we do our quotient property. So we're going to take where we have subtraction and do our division. So this is going to become our log base 5 of the fraction that has our z to the 6th over our x to the 7th, y to the 8th. We're getting it down to a single log. Let's do one more. We'll do the left one and do the right one tomorrow. So let's do the left one. We'll have this one be the last one for today. And we'll keep working with our condensing and expanding tomorrow. So we're just going to do the left one. And the longest it'll take for us to write it out will be the first time. So we have our log base 3 of 4 minus our 1/2 log base 3 of 6x minus 5. What are we going to start with? The 1/2. Start with taking our coefficients up to become powers. So this is going to become log base 3 of 4 minus our log base 3 of 6x minus 5 to the power of 1/2. That does not work. You could put to the power of minus 1/2 and switch to be a plus, but you're going to wind up at the same final expression anyway. What are we going to do next? A fraction. This is going to be our log base 3 of the fraction that has my 4 in the numerator. And our whole expression down here is 6x minus 5 to the 1/2. How else can I write 6x minus 5 to the 1/2? The square root. So this is the same thing as log base 3 of 4 over the square root of 6x minus 5. And that's fully condensed down because my log has only one expression. I prefer you write them back out as radicals like this, but if you leave it like this, it's technically okay. Justin and Marvin. No, we are going to finish 5.5 tomorrow, so it won't be due until we get back from break. That's for you, and that's for you.